You guys can see the screen still? Okay.
Sir, it's stuck.
Yeah, just a minute. I got disconnected. I just came back. Can you see now?
Yes, sir.
Yeah. Uh, I had started
Yes, sir.
IXX. So I substituted the value for I1 plus A1 H1 square. Now I'm substituting the value for I2 plus A2 H2 square.
हेलो सर.
Yes.
सर आपकी वर्ड फाइल वाली स्क्रीन दिख रही है हमें अभी. नाउ इट्स लुकिंग.
Yeah. Okay. I think there is some delay. Nothing can be done. It's very cloudy since morning. So there is some problem with network. Okay. And now the last one is I3 plus A3 is 2500 into H3 is 258.75 square. Okay, so now I have substituted all the values. Please have a habit of writing the unit whenever you substitute the numbers in the equation, right? See here, when I am just representing I1, A1, H1, so I cannot write a unit here, but here definitely you should write unit. So this will be mn raised to 4. So Ixx is equal to, let us calculate this. It's all huge numbers. I have I1 already plus 1500, 15,000 into 91.25 square plus, just copy this plus 7500 into 96.25 square plus this plus 2500 into 258.75 square. So it's a huge number that I have got. Just put it here. So this many mm raised to 4. Okay. Now we have calculated the moment of inertia. Let us go to the question. It is a UDL and simply supported beam. Okay. I'll just move this. All right. Now I'll just draw a UDL. This is my beam, and on this I have to apply UDL like this. I'll just fill this. This is easy for me. So there will be a reaction at the bottom on this side, and another reaction here. I'll name this point as A and B, and this is W kilonewton per meter. Okay, this is my given. Now Since there are no other loads, so the reaction should be equal to the half of the UDL on both the sides. So support reaction RA plus RB will be equal to W into this span is 4, so into 4, right? So 4 times W, or RA is equal to RB, and that is equal to W by the 4W by 2, so it will be 2 times W kilonewton. Okay, because I have taken here kilonewton per meter, so this W whatever you get will be in kilonewton per meter in the end. Now I have the reaction. I need to find the maximum bending moment. At A and B it will be 0, so the maximum bending moment will be at the center. So Bm max is equal to, you can take left side or right side, anything. So reaction is 2W into perpendicular distances 2 meters minus W into 2 into 2 by 2. So this will be, again this 2 into 2, it is 4W minus 2W. So this will be 2W kilonewton meter. Okay, that is the maximum bending moment. Now I have to put this in the bending equation, right? Uh, bending stress is equal to my by I. Don't use m by z here because he has said, he has given the stresses differently. The permissible stress in bending are 120 120 megapascal in compression and 40 megapascal in tension. See, the fibers above this XX plane will have compressive stress, and below this plane will be tensile stress. So we need to find the load according to these two. Whichever is the minimum, we will be using that one. Okay. So now I am considering the compressive stress, that is on the upper side, considering compression of beam 120 is equal to, how much is m is 2W. This is in kilonewton meter. All my dimensions are in mm, so I'll convert this into mm, Newton mm. So this will be W into 10 raised to 6, right? That is my m. Y is from this point XX to the topmost surface, right? So how do you calculate that? Let us calculate the total height, that is 75 plus 25 plus 300, that is 400. 400 minus y will be this diff length, right? Minus 128.75, that is 271.25. Okay, so this is my y. I value is this much. Okay, so I'll have to calculate this. My by I, mm, sorry, this will be megapascal, because this is stress what we are calculating. Now from this I can calculate W. So it is 120. This will come here as multiplication into 425169270.83. Correct? Uh, Divided by 271.25 is this much, divided by 2 divided by 6 10 raised to 6. So W is 94.05. W is equal to 94.05 kilo Newton per meter. Right? Now considering the compression stress, I'm getting W as 94.05. Now let us consider the tensile stress and find the W. Considering tension of beam. So tensile stress is given as how much? 40 megapascal. So 40 is equal to, this will remain same, 2 times W into 10 raised to 6, right? Now what will be this? Y? Y is this one only, because that is how I calculate from the CG. The bottommost fiber is 128.75 divided by 425.169.270.83. Okay, MPa or W is equal to, I'll just copy this, 40 into I value is this, by 128.75 is this, by 10 raised to 6 by 2. So this is 66.05 kilonewton per meter. Okay, now I have a question. By considering the compression in the beam, the load that I have is 94.05 kilonewton per meter, and considering the tensile stress in the beam, the load that can be there on the beam is 66.05. Of this, which one should we choose? Greater one or lesser one? Yes? Any answer?
The question?
Question is, see, I have 2W in this. Considering the compression in the beam, see, above XX plane, this is the neutral axis. Above this, there is compression, and below this, there is tension, right, in the beam. Now, considering the compression, the load that can be applied here, this is the load, UDL. Maximum load that you can apply is 94.05 kilonewton per meter, and considering the tension, the maximum load you can apply is 66.05 kilonewton per meter. Which one should I select as the maximum load for the beam? I cannot have two load for W, right? This cannot be two values. It has to be one value only. Of this, which one to choose? That is the question. Is the question clear? No idea? Okay, let me tell because time is about to get over. See, always we have to choose the lower value, right? The load that is being applied should be selected whichever is lower whenever you have this tension and compression. You are considering tension and compression. If I get the minimum load for compression, I have to use that load. If I get minimum load for tension, I have to use that load. Reason is, see, when I apply 94.05 kilonewton per meter, the beam will not fail due to compression, but it will fail due to tension. So what will happen? The bottom fiber uh, or the fibers below the neutral axis, right? This region, this larger web, that will get elongated. If it is ductile material, it will have plastic deformation also, right? And upper fibers, nothing will happen. Now in this case, W due to tension is less, 66.05, right? So if I apply more load, this will fail. Now if it were to be ulta, if tensile stress, considering tensile stress, the load is more, and considering compressive stress, the load is less, and you apply this load, right? Considering tensile, whatever is there, if you apply that load, the beam section below the neutral axis, that is, which is subjected to tensile stress, will not fail, but this portion there will be compressive failure, right? So for this reason, if I use a lower load, now if I put W as 66.05 kilonewton per meter, then definitely compressive also will be safe. The beam will be safe in compression as well as in tension. Is that clear? So we have to use always the lower value, not the higher value. Meeting will end in 5 minutes. So quickly let me write that here. So the max load or UDL that can be applied on beam is 66.05 kilonewton per meter. Okay, you have to write like this. Is this okay? Clear to everyone? Yeah?
Yes, sir.
Okay, then we will stop at this point. Uh, we will take more numericals in the next class.